Your serverless application scales instantly on AWS. But your database? It hits hard limits. Traditional databases can't keep up with unpredictable traffic spikes, causing slowdowns or failures. DynamoDB solves this. Fully managed by AWS, it offers single-digit millisecond latency at any scale. Zero operational overhead. AWS handles nodes, disk space, and failover. But there's a catch. This convenience requires designing your data model around queries upfront. Changing access patterns later is painful. For AWS teams with well-defined access patterns, DynamoDB is the battle-tested NoSQL powerhouse. How does DynamoDB achieve this scalability? Inside, data is stored across SSD-backed partitions. When you write an item, DynamoDB hashes its partition key using consistent hashing to determine which partition holds it. Each partition supports up to 10 GB of data, 3,000 read capacity units, and 1,000 write capacity units. Use a low cardinality key like date, and all writes for today hit one partition, creating a hot spot that causes throttling, even with sufficient table capacity. Avoid this by designing with high cardinality keys to spread load evenly. Data is replicated across 3 availability zones. 1 leader handles writes, 2 followers serve eventually consistent reads. For strong consistency, reads go to the leader. This quorum-based replication ensures 99.99% to 99.999% availability. To optimize queries, DynamoDB offers secondary indexes. Local secondary indexes share the base table's partition key but use a different sort key, enabling sorting within a partition. They must be created at table creation and share the 10 GB limit. Global secondary indexes have a new partition key. They're like separate managed tables with their own partitions and throughput, updating asynchronously. The real power comes from single table design. Store multiple entity types in one table by overloading keys. For example, pk equals tenant hashtag 123, sk equals profile for tenant data, and sk equals order hashtag 2024-001 for orders. One query call returns all related data for that tenant, enabling fast, single partition queries. This pattern plays to DynamoDB's strength, targeted, efficient access without scans. With these design patterns, how do you manage capacity and performance in production? DynamoDB uses read and write capacity units. One RCU provides one strongly consistent read per second for items up to 4 kilobytes. One WCU provides one write per second for items up to 1 kilobyte. Use provisioned mode with autoscaling for predictable workloads, targeting 70% utilization. On-demand mode costs about 6.5x more but handles spiky traffic. For event-driven architectures, turn on DynamoDB streams to capture changes and trigger Lambda functions. For read-heavy workloads, add DAX, an in-memory cache that drops latency to microseconds with write-through caching. DynamoDB excels for serverless apps, gaming, IoT, where access patterns are well-defined. Pros: fully managed, scalable, low latency. Cons: vendor lock-in, expensive at scale, 25 GSI limit per table. Avoid it for complex relational queries or multi-cloud needs.